anyone have a problem with recording this? Cool. Okay, 29 out of 47. All right, they're very good. Why you guys all here so early?
7 minutes.
7 minutes? Yeah, long time to wait. Anyone have pre-class questions? Problems? Oh, no, they can sit here now. Yeah. Yeah. You can do this on your phone. I think I'm big enough. How many people have the book already? Okay, 2 people. How many people are planning to take the series after this, the 10-10 series? There's Astra 1000, there's Astra 1010. Did anyone know that there was another class? Okay, cool, neither did I. So actually today, before I came to this class, I was writing the syllabus and I realized it had so I've taught this class a couple times for majors. I've never taught it for non-majors. And it's called Introductory Astronomy for Scientists. And I was like, well, that's not the name of this class. So I went online and it's Introduction to Planetary Astronomy. I was like, oh, that's not what I thought. And then I looked at the course catalog description, which I had copied into the syllabus, but did not read, because I guess no one reads the syllabus. And it turns out that we're only going to be learning about planetary astronomy. So there's a whole nother class that talks about stars, galaxies, etc. If you're disappointed already, I promise you, planetary geology, planetary astronomy is actually really cool, better pictures, and I'm more interesting. But if you only came for stars, you have to wait for the next semester. So, and we'll talk about this a little bit. There is like a smaller version of the textbook, which is just called the Solar System. This is the 8th edition, but whatever, the same material. And then this is the big one, obviously. And I think this is 7th. So that's how long I've been teaching it. Oops. Okay. Questions before we get started? I know we're still 3 minutes early. I'm really just trying to burn time because I got here way too early. I've never been in this building. My first time in this building, first time in a classroom this large that is not on Zoom. Yeah.
I know that we have the mastering astronomy.
Mhm.
I know that there's 2 assignments. One assignment is due in 2 days. Will those assignments affect us, like, if we don't do good on them?
So the first one, I believe, is just like welcome to mastering, and there's 0 points for that. Like, you don't have to worry about that. That's just like, how do I use the machine? And then the second one, and we'll talk about this a little bit when we go through the syllabus. I think it's due on Friday, so that's 4 days. If it's too long and no one can do it, let me know. I take feedback really well. So if you want a whole week to work on it, let me know. It's just like, we're gonna have a lot of stuff that we're doing. We'll talk about the content schedule. Has anyone been on Canvas and already like read everything there? Oh, good. Okay, perfect. So that type of motivation is great, but probably you're gonna find that I'm more lenient and my schedule just like moves because I like talking too much. Okay. Any other questions? Okay. So we are going to get started. In case you haven't guessed already, I'm Dr. Hizmani. After you introduce yourself to me and I get to know your name, you can probably call me Mateo. If I see your nose right now, you should be wearing a mask. Okay. We're going to revisit that on the 16th of September. What the university tells us we can or cannot do. You choose to wear masks the whole semester. Nothing wrong with that. In fact, we have stuff on Zoom. It's better if you attend in person because we can interact with one another. You can interact with your peers, right? Okay. So this will be Introduction to Planetary Astronomy. What you see here is what is this? That's the solar system. Okay. So I like to run my classes like a game show. And the way that we're going to play it for no points and no money is that I'm going to ask you a lot of questions. You are allowed to guess whatever you want. Okay? Within respectful, reasonable boundaries. And what we're really looking for is to sort of like get your brain going. I know that it's 4 o'clock, a couple days back. Like, oh, I didn't have enough coffee. That's so annoying. But I promise you, it will be fun, kind of. Okay? Yes, any quiet? Okay. So what's this on the left-hand side? Someone raise their hand and tell me what it is. Yeah, no worries. The sun. Very good. And what's this? Jupiter. Is there anything wrong with this picture? Jupiter's all gas. Is that what's wrong with this picture? No, I did not. Okay, and remember, we're raising our hands. Go ahead. Is the order wrong? Not the order. Yeah. Okay, yeah, so something about their relative positioning maybe seems a little unusual, like they're not really normally all lined up like that. Are they that close to one another? No. No. Okay. Could we put them on a page? I guess we'll find out, right? Okay. So here's who I am. I went to UCSC. I got my Bachelor of Science there in astrophysics. I went to CU Boulder. I got my PhD there. I spent a couple years at NASA's Goddard Space Flight Center. That's in DC. We worked on a TGO mission, which is the European Space Agency mission to Mars. So I like Mars, surprisingly. Here on the left-hand side, this is the MAVEN mission. It just so happens it's also on here. This is the mission that I use the data of. And my claim to fame. Anyone here, raise your hand if you know what a shooting star is. Okay, you've seen a shooting star before? Raise your hand if you know what it actually is. Not a shooting star, but a. What was that? The ball of fire, that's correct. And the technical term is? Good, it's debris entering the atmosphere. They're called meteors. How big are they? Talking like basketballs, size of this room.
Range of size, it's a range of size.
What's that?
A range of size.
Right, but the ones that we see. They're about this big.
Oh, I thought meteorite was that.
Well, when we collect them off the ground, they can be much bigger than that, but the ones that we see, the visual meteors that we see, tend to be about this big. Sometimes they're that big. How does that happen? They're moving at like 30 kilometers per second. They're so hot, they vaporize entirely, and they go in the sky. Okay? So I found that at Mars. That's my claim to fame. Okay. Questions about my background?
What's UCSC again?
Santa Cruz. Santa Cruz.
Oh, yeah, oh, yeah.
Okay. Remember, we're raising our hands for questions. Okay. 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 So if there is one thing you could do to improve your grade by half a letter, would you do it? Raise your hand if you would do it. Okay. Almost everyone. What do you think that thing is? Not texting during class. It turns out that it's pretty straightforward. The more you text in class, the less you will do well, because the things that I say translate into what you understand, translate into your ability to not be paying attention while you have a question, right? So like, let's say you're not really following along, like just talking to your friend, and you don't understand what's happening. The reason that we have lectures at all, and you don't just read a book, is because you're like, I don't get this. What the hell is going on here? And I say, oh, it's X, Y, Z. Oh, that makes more sense, right? Okay. We're gonna do something called lecture tutorials, break up the just lecture style. You're not just sitting there, the things move your own on and on. We won't necessarily do one today, but as we go up through the semester, these things are basically designed so that they have some simple premise, and you're gonna like have a conversation with people, or you're gonna investigate some topic, and it's going to develop as it goes, okay? These answers will not be posted. If you want to come to office hours, we can talk about the answers there, and they may or may not show up identically on a midterm and or final. Participating in them gives you points. You put your name on them, give it back to me, I'll give you points. Cool. Okay. Do you have questions about like the exams, textbook, help sessions, mastering astronomy? Oh, I said exams twice. Wow, I'm smart. Okay, so all of this is in the syllabus on Canvas. We can go over that together, or do you want to just do it on your own? Raise your hands if you want to do it on your own. Okay, perfect. So let's go over here. Nope, that's not right. Okay, so there's two components in this class, or two of the things that I'm going to show you. This is all the information we've basically already talked about. That's my name, that's how to contact me. My office is in physical sciences. You walk by my door and it's closed, just knock. If you don't hear any response, knock harder. And then if you don't hear any response and the light's off, I'm probably not there. Okay. We have office hours, like student help sessions. They're before noon today and on Thursday. We'll also have one tomorrow at 1 or because we have Zoom. If you have a question, just jump on Slack, send me a message like, can we Zoom 5 minutes? I have a question. Cool. Okay. Within reason, not at midnight. Okay. Question about that? No questions about anything. All right. So let's talk about this. Here's the statement. You can ignore that. This is the discussion of what we're going to talk about today. Prerequisites. No specific coursework or experience in astronomy is required. In fact, very little math will be required. A lot of what we're gonna do is comparative planetology. So doing fractions, necessary. A tiny bit of algebra, necessary. Deriving equations, no, don't like it. Okay. This is some information about the course book itself. Note the difference here between the solar system and the cosmic perspective, depending on if you're taking the 10-10 series. This is what we're essentially going to cover in that book. It's a good idea to do the readings, but if you want to do them after we have the discussion, that's totally up to you. At some point, it's just fun to go through the book. I think it's a pretty good book. I'm saying that as an astronomer, so maybe I'm biased. But like, it's fun. There's like cool pictures and cool diagrams and stuff. If you hate it, let me know. Add that in the FCQ. What are they called? SOTIs? Yeah, add that in the SOT. Okay. So I already talked a little bit about the lecture tutorials. This will be a portion of your grade. There is a cool website that's called Stellarium. It's a free planetarium software. You can download it for any computer. You can like look around like what the night sky is going to be like tonight, so you can impress your friends. Or you can just grab the app. This one has a lot less functionality because it only shows you exactly what you're looking at. I think it's called Skyview Lite. Don't pay for it. Silly. You just always have to close out of that. And then you point and it shows you which stuff is using AR. So pretty fun. We're going to use Slack as an alternative method of communication. You can always email me, obviously, but Slack is like for quick answers, right? What is blank? Boom. You can also post to the group there. So if you have a question, you feel like someone else can answer it, put that in there too. Okay. Oh, this is not true. I have to delete that. But when we have office hours, you want to come in and just chat, whether that's about science or space or life or anything, you're welcome to as well. Mastering homework, some of you have already figured it out, some of you have not. That's totally okay. There's a code that goes with your textbook, or you can just buy the code only if you already have a textbook or a friend lending it to you. And that's just how we're going to do our homework, because grading homework for 47 of you is tedious. The ability for us to use mastering homework or mastering is that it has pictures on a screen. Are really cool because as we'll see, most of this course content is about like, I show you a picture, I ask you what you're looking at, and you interpret the picture. Okay? That's why I said it's like a game show. Okay. Yeah.
Is that like mastering physics?
Yeah, exactly the same, except it's not as annoying. So for mastering physics, you put in like the wrong number and like 7 times in a row. It's awful. This one, at least you just drop downs.
Way back.
Yeah. Okay, there are yeah. So there are observatory open houses. Okay. Easily attained points. What does this mean? Every 3rd Thursday, you go to the observatory, you look at whatever they're looking at in the sky, and then you write about it. There are, I think, 4 opportunities. You need to go to 2 to get, let's see where it is. 10% of your grade. Basically free, right? Yeah. So it's behind us. If you go out this building and you look up the hill, there's a little road. So you can either drive up that road, you can walk up that road. There's parking at the top. Depending on how many people are there, it may be limited. Okay. Yeah. It's the 3rd Thursday. Yeah.
If I want to go to the
Yeah. Go to as many as you like. Yeah.
On Thursday, are those like an all day thing?
No, sorry. Sun has to go down. Right?
Uh-huh.
There'll be an email to the whole campus, right? So we tend to say like, oh, open house, anyone can come. If it turns out that like you're really interested in going to the observatory, but you never get any time during the open houses because they're too full or whatever, we'll have class only open houses. Whatever that means. Okay. Okay. Yeah.
anyone from, like, does it have to be the student here or?
No. Open to the community, bring your friends, bring your family, whatever you want. Okay. Anything else? Okay. There's a midterm and a final exam. Mastering is pretty easy to cheat on. You'll find that out if you've been in college at any amount of time. You can just go onto something like Chegg and you can get all the answers that you need. That's a choice. I would prefer you don't do that. I think engaging with the material is one of the ways that we learn. And I think in particular, it'll really screw you up here. Right? Because you could totally just show up every day, not really pay attention or like listen to me kind of like make fun story time. And you come in, you get 15%, maybe you go to the observatory open houses, now you have 25%, you get your mastering, and now you're at 65%. And then you just bomb these two. Right? That's not a very fun grade. This is supposed to be a fun class. So engage with the material. If it's too much in one setting, or if it doesn't make any sense, or if it's not a good resource, let me know so that I can change it. Okay? Yeah.
Back to the open houses, you stated that we have to make sure we send in with you when we arrive. Is that like an email or?
No, I just have a piece of paper.
Okay.
Write it down. Cool. Did you have a question? No. Okay, cool. All right. This is something that I stand by. If it looks like you're working hard and putting in effort, I'm going to make sure that you do well. Okay. Astronomy is not for sure. Okay. Grade averages, late assignments, blah, blah, blah. In particular, in the classroom, we are going to use respect when discussing one another. We're going to use respect when addressing one another. If people have a diversity of opinions, or if someone is doing something that you don't like, let me know right away. Okay, I'll make sure that it gets taken care of. If you're acting disrespectful to anyone else in the classroom, you will be asked to leave, potentially from the whole class. Okay? Everyone abides by this. Forms of disrespect. If someone says, hey, I really go by my middle name, Michael, and you call them by their first name. If they go by a different name, they've chosen a different name than is on their ID, and you call them by that name and not the one that they have chosen, that's a form of disrespect. You call me, yo. You get my attention? That's a form of disrespect. You see how that all fits together? If I choose to go by he, him, which I do, and you choose to go by something else, we're going to try and respect those. Now, you may not be perfect. Okay? Sometimes I make mistakes. I'm very, very bad at remembering people's names. Horrible at it. I don't know why. Okay, you're going to introduce yourself to me. 2 seconds later, I forgot your name. It's not because I don't respect you. It's because I'm terrible at it. Okay. Once I get to know you better, especially when we don't have, like, we're outside and I can see your face and put you together as a person, it'll be a lot easier for me to understand. Cool. More questions about this? Yeah. Yes. Okay. Yeah. So physics, there is a physics class, and inside there's a channel. The channel you're searching for is Astro 1000, fall 2026. That'll put you directly into a group with everyone else. All right. You can join any other groups. I'm teaching a computational physics class right before this. You can join that if you want. You just listen to us talk about computational physics. Okay. Here is another thing you'll find, and which of course I broke this morning when I realized that in fact we are not doing galaxies and stars. So I'm going to fix this. All the content is going to be here in the right order at some point. You've already had labs, or I think 41 of the 47 of you, if I'm not incorrect. So we're gonna try and tie these together. You'll see them there on the left-hand side when the lab reports are due. That grade does not affect this class or vice versa, but obviously if you're participating in both, you'll do better. I'm gonna try my best to work with Riley to make sure that they're paired together. So you're seeing the content at mostly the same time. Okay. There is the mastering. That's when it's due. If we have to change that, that's totally fine. This is the phase of the moon. And then there's the observatory open house. This is the percentage of the phase. So when it's 95% full, that means it's very bright and shiny. And when it's 3% full, not so bright and shiny. Okay. Questions before we go back to the presentation slides? Okay. Okay, rather than continuing to joke on my thumb, let's do this. Okay, so what's this, by the way? Raised hand. Yeah, what's that? What's that? It is a star. Does anyone know which star? Nope. Yes. Yes, it is our favorite star. It is the source of all life. It is the source of all energy. Great. And it's the only one that we can have multiple pixels on. Every star that you see in a photograph, like a circle, not a circle. That's the optics of the telescope. Okay, they're all points, just very, very far away. We'll talk about why that is a little bit later today. Okay, so this is what you wanted to know about. So some of you filled out the pre-survey, and I put it into a little like word smusher thing. Most of you wanted to know about planets. That's great, because that's what we're going to talk about. Your favorite planet was Earth. That's awesome. I saw Mars in there. But it wasn't as big as Pluto, so I don't know what that's about. Fine. And Saturn was actually more important to folks than Jupiter. I guess because it has rings. So some topics in here that we won't be able to get to, like the Big Bang. Life in the solar system we will talk about, especially if you're interested in questions of like, is there life in the solar system? What is a potential reason why there may or may not be? Someone put in here meteors a couple times. That you're studying ahead of time. So we can talk about that if you're interested. We're going to keep coming back to this. If you have thoughts or you're like, we really want to know more about that, there's some flexibility in the schedule. Last semester, I just like created some lectures. So for example, people were like, I really want to know about time travel. I just made a lecture on time travel. People wanted to know about like when the rocket age, when we started going to places and how we did that. So there's a lecture on that I can just whip up if people want. Okay. Cool. So what is this class about? I want you to learn critical thinking skills. Okay. You may already have this. We're going to apply this to planetary system. Okay. So we're going to reason. We're going to talk scientifically. We're going to grab evidence. We're going to learn why the solar system looks like it does. We're going to learn how it got to be that way. And we're going to see what we do and what we don't know about the solar system as a whole. Okay. What are these things again? What was that? Planets. Good. Good. What's this one? Is that a planet? That's the moon. Good. Are these in the right order? It'd be kind of silly if they weren't. Actually, they are in the right order. So this one up here is Mercury. This one is Venus. This one is Earth. This one is okay. This one is good. This one is Uranus. This one is very good. Where's Pluto?
It's gone.
It's not a planet. What the hell? Okay, so here's what we're going to do. We're going to start off talking about size and scale. We're going to try to understand our place in the universe and why like the day-to-day is like really not that big a deal. So this is us, fits into there, that's the solar scale, not to scale, fits into the galaxy, fits into the local group, fits in the local cluster, and inside the universe. It's mind-boggling. When you start to look at astronomical numbers, right, you think about something like, what's the largest amount of money you think you'll ever make in your life? Maybe in the millions, if you add it all together. You look at like a billionaire, like, wow, that's a lot. Times 1,000 what I'll ever make in my life. Okay. To think about the scale that we talk about here, like the number of atoms, say, inside of this water bottle, is like 10 to the 26. So that's like multiplying 10 with 26 zeros. The numbers that we're thinking about when we think about how far things are, they're just not normal numbers. And we'll demonstrate that today. We're going to talk about how the position here on Earth affects us, what we see. So we'll talk about this thing called celestial motions. This is the motion, the sun in the sky. This is the motion of the moon in the sky. We're going to talk about what eclipses are, moon phases. Why do they have phases at all? What does that tell us about astronomy in the first place? And we're going to talk about stuff like this. Which one's this? That's what? That's Mars. Why do we know it's Mars? Yeah, color. Okay. So one thing that I want to do here is we're going to start paying attention to the color of things. We're going to look at the morphology of things. And we're going to try and infer stuff from it. So the fact that there's a hard surface tells us that it's not Jupiter, right? Okay, and what are we looking at up here on the right-hand side? Well, that was the heat shield impact. That's correct. But actually what you're looking at is you're looking at a lander descending and falling onto the surface. So that is the heat shield right there. And they watched it go down. Okay. And this thing is in a parachute. Okay. So in the bottoms here, you'll see that it has ice caps. Ask, please. You'll also see that there are clouds on Mars. So if you didn't know that it has an atmosphere, in fact, it does. Study it. So I have a little bit of a vested interest in telling you that. And here you'll see what the rovers look like when they look out of the window. Okay. It's hazy. A little bit like Utah. If you've ever been to Utah. Or the desert. Ever been to the desert. Okay. It's dusty. Okay, we're going to talk about why do they look like this. We're going to talk about us and our nearest neighbors. So which one of us is us? Yeah, that's obvious, right? The one with the biggest clouds. Oh, wait, what's that? Yeah, that's Venus. Tons of clouds. Huh. Maybe clouds aren't all there is in the world. And this one here is Mars. Very good. Okay, so we're going to talk about why there is life on Earth, but no life on Mars or Venus that we can see. Okay.
I thought Mars was supposed to be red because of the red.
Red is a matter of color perspective. That's reddish. Right? Okay. We're going to talk about why Earth is so different from Jupiter. This is them to scale. You'll notice that the Earth fits right into this giant storm that you've heard is called the red spot. There is no surface on Jupiter. You fall into Jupiter, you just keep falling until you're crushed. At the very center is a very strange form of matter called liquid hydrogen. Hydrogen is very light, but when you have a lot of it, you press it all close together, you smash it, and it becomes like this liquid metal. Okay, we're going to talk about why that is. This image is a little old. You may be following in the news. You've seen that there's a recently deployed JWST. It's a new space telescope. And what you'll see here is some of the newest releases from that space telescope. So this is the same planet, that's Jupiter. And you see that same storm here, but you're looking in infrared. Okay, so this is the light that actually we give off. So if I were a snake, I could see in the infrared. That's how snakes see. I can't see in the infrared. Anyone here have full, partial, or color blindness of any type? Men are more likely to be colorblind. You may not even know you're colorblind. You can take like color acuity tests. So your ability to see color in the way that we talk about it is kind of limited to what we think colors exist, right? So you say, well, is that a real picture? That's a real picture. It's really what it looks like, just in a wavelength of light that we don't have access to. Okay. Anything you see unusual about this picture? Bottom right here. Yeah. So that's the big red spot that we just saw there. Good. Anything else? Yeah. Yeah, that's correct. So this here is glowing at the north and south pole of Jupiter. Those are called aurora. You may have heard of these before. They're called the northern lights on Earth, or if you go to the south pole, they're called the southern lights. And what they are is they are particles from the sun slamming into the atmosphere and releasing their energy. They happen on Jupiter. Jupiter is massive. You look at just the size of Jupiter, you say, oh, that's cool. But then it has what's called the magnetosphere. That's where each magnetic field connects. And it is much, much larger. So it grabs all of the particles from the sun and directs them to its poles. Okay. What's this thing right here? Yeah. What? Ah, that would be great. That would be great to get both of them. But in fact, JWST is very close to us and we can't turn around and point it at ourselves. Otherwise, it will fry the cameras. This is one of the moons. You've heard of 4 moons before, probably. Io, Ganymede, Callisto, and Europa. It's not any of those. This is a much smaller moon called Amalthea. There are 67 of them around Jupiter. And you will see something really interesting in this image, and from any image from JWST. Notice how it looks like there is a little like 6-pattern star. That's how you tell that it's a JWST image. Okay. All of the rest of telescope images that you've seen probably have had stars that look like this, right? So that's from the typical optics that you get when you just have a circular telescope and you have to use a crosshair to put a primary mirror in the middle. You'll see this in a lab to be able to touch it. Okay, that crosshair is literally shown on the picture. But JWST doesn't use that. It's a giant hexagonal mirror. Giant, like 36 feet across. And because it's a hexagon, you get a six-sided shape. So in fact, you see that here. And when you look at these slides online, you'll also see that off of the aurora, there is a diffraction spike that has 6 sides. It's pretty wild. Okay. That's one of them. Here's another one. These pictures are just stupidly cool. I don't know what to tell you. I love space, so I'm mostly gonna sit up here and just be impressed by how cool space is. If you don't like space, that's the wrong class. Okay. Okay. Questions?
What's that one called again? The one with 6 sides?
It's a diffraction spike.
No, what do you call it?
Oh, the actual moon here is Amalthea.
Almo?
AMATH. Oh, okay. Actually, ask me on Slack. I'll just send you it there. Not a good speller either. Things I'm not good at. Spelling, arithmetic, Amalthea. Spelling, arithmetic, remembering people's names. So we're going to talk about what's the deal with Pluto. Why don't we refer to it as a planet anymore? In order to do that, we'll have to do things like defining what a planet is. Here you see that's Pluto. It has a moon. The moon's name is Charon or Charon or Charon, depending on how you want to pronounce it. There's another one called Eris, and Eris has a moon called Dysnomia. And you will see that these are all to scale. In fact, here in the bottom is the Earth to scale to show you their relative sizes. So it starts to get into this discussion of, well, Pluto's going to be a planet, then all of these have to be planets. And then where does it stop? Is any rock a planet? My cantaloupe a planet? So you had to make a definitional argument there. And in fact, very recently, recently in like historical context, we went there. So up here in the left-hand corner, this is real footage actual images of Pluto. And we'll go into that in a lot more detail. We'll talk about the geology of how water, ice can act like rock, and how nitrogen ice can act like soil. Very weird. Get far enough out in the solar system, everything is basically a rock. Okay. We're going to talk about the ways in which other solar systems are like us, and in which ways are they different. So we're going to form theories about the formation and evolution of planetary systems. And hopefully that's going to inform us as to how do we get to where we are, specifically like us. I'm gonna have a whole lecture if you're interested on the timeline of all time, where you start right here and you just work backwards to the start of the Big Bang, then you go forward as to what's gonna happen. Okay? Let me know if you're interested in that one, otherwise we can skip it. Course is not memorizing constellations. You just want to do that. No value. It's fun. You sit up there and you're like, oh, I know what that is. But it's not like something that you want to take away from this class. You're like, oh, I really learned all 36 constellations. Okay. If you're going to take ASTR 1010, I guess I'll kind of breeze through this stuff. It's going to talk about what makes the sun hot. Why is the sun hot at all? Anyone know what that is? Remember that we're raising our hand. Let's see if anyone else. See if anyone else. Only a few people can know. Yeah. What's that? Earth. That's a very good question, or that's a very good guess, because you know it's circular and it's very small. In fact, this is Mercury from Earth. Okay. So Mercury will pass in front of it, and you'll see up here. I mean, this is absurd. You see how big these are? These are prominences. This is material flowing off the surface of the sun, exploding off the surface of the sun, and they're much larger than a planet. So this whole temperature, the whole surface, the temperature is about 6,000 degrees Celsius. So nothing survives, of course. Okay. Oh wait, what's the joke? Why don't we ever go to the sun? It's too hot. Why don't we just go at night? There we go. No one cares. Okay, so do stars exist forever? We'll answer that question. You'll notice here, what telescope took this photo? Yes. Close. That would be a space telescope. So it is in space.
I don't remember the name, but I do know that's the new one.
The new one. You know this is the new one because it has 6 sides. Any photo you see with a singular object with this 6-sided star pattern, that's JWST. Nothing else will have it. Everything else will have the crossbars, which is awesome. Because now we can always refer to these ones. It's really easy to tell the difference. Okay. So this one is a picture of what's called a planetary nebula. Nothing to do with planets. They just don't know how to name things in astronomy. We'll talk about how stupid that is a little bit later. Like dark matter, really? No, can't see it. It's dark. Okay, we'll talk about, or we won't talk about this. If you take 1010, you talk about whether or not interstellar is accurate. The black holes are good. The idea that love is a pervasive force that can somehow affect it, not so good. Okay, we'll talk about what kind of galaxies exist. You'll see in this picture, this is the JWST deep field. So they just stare at one part of the sky for a really long time. And that's a star. You can tell because it's got the patterns on it. And anything that doesn't have this on it, so these are stars. But this is a galaxy. That's a galaxy. That's a galaxy. That's a galaxy. That's a galaxy. In fact, every single every dot of light that you see on there is a galaxy. And the ones that are more red are farther away. Okay, so in fact, they found one of the oldest galaxies, like right after the universe was born. First time that you can see stuff, first galaxies, big gorgeous. We won't learn about them. We'll talk in 1010, you'll talk about how there could be an edge to the universe, how everything could just into existence. And we're going to talk a little bit here about the nature of science. So we'll come back to this question in maybe a few minutes, but maybe a few days. Okay, questions before we go into content. Just told you about what everything we're going to. Okay. So we talked about this. So what was wrong with this picture? Someone who hasn't talked already? Yeah. The spacing between them is incorrect. Okay. So in this scale, they are actually the right size relative to one another. So these are the planets here. These are the dwarf planets. And in fact, you'll see again why Pluto doesn't get to make it. So not only is it not alone, it's Pluto, Haumea, Makemake, and Eris in that order. But also there's something called Ceres, which lives in here in the asteroid belt, which is big. It's a giant asteroid, largest asteroid. And so if that's not a planet, what is Pluto get? Okay, so we're gonna have some fun. You may be wondering why I brought my lunch into work today. In fact, I did not. We're gonna build a scale model of the solar system, and we're gonna need some volunteers. 2 volunteers to start with. 1, okay, you're gonna be the sun. Come on down. This will be the sun. You stand there. And I need another volunteer. Come on down. Okay, so the first thing that we're going to do is we're going to try and build a 1. Oh, these numbers always bottom. Okay, so it's you start from this side, you go 1, 2, 3, that's 1,000, 3 more, that's 1,000,000, 3 more, that's 1 billion, 1 to 10 billion scale. So we've now shrunk the sun down to the size of that grapefruit. Okay. So where does the rest of these objects go? So first, let's ask the question, where does Mercury go? How big is it? Which of these objects is Mercury? Is it this one? No, it's not bigger than the sun. Yeah. Yeah, these are blueberries here, and these are grapes. Okay, so we have a vote for blueberries. Does everyone think blueberries? Okay, hot, bigger or smaller than blueberries? Smaller. Okay, here's some votes for smaller. Okay, what about the icebreakers? Let's look at the actual questions. Does that seem right? Okay, so people take Mercury. Here's Mercury, please. Okay, and now, I'm sorry, what's your name? Richard. Richard and Megan. Okay, so Richard, you're going to start walking. And no, Megan, you stay. And hold on. So now let's find out where we're going to place Richard with respect to Megan so that it's the right size and scale. So you start walking. Someone says stop from the group. You're gonna have him walk forever? Okay. So what do you think that is? How many feet that is? A little bit more than 6 feet, maybe? Is that right? Bigger or smaller? Yeah. Smaller. You think small? Okay, so go a little bit closer. All right, raise your hand if you agree that that's the right distance. Uh-oh. Okay. Now come towards me, Richard. What about that? Raise your hand if you agree. Is he supposed to be in this room? Do I need to send him out? Is that the right scale? Okay. How many people know the correct scale? How many people are listening? Raise your hand if you listen. Okay, so your arms do work. Okay, so you just don't believe he's far enough away. Okay, so let's keep going, Richard. What about that? No? Okay. That's pretty far. Pretty far. Okay, go ahead and put the that niche down. So that was Mercury. So next is Venus. How big is Venus in comparison to that? Which one of these objects? Blueberry. Okay, so you said, well, this is small, this is slightly larger. Let's put one and one together. Okay. And Venus. Can I have a blueberry if you want? You can also have that mint if you want. All of these are, I just bought today. They're all fresh. Okay. So now we're going to direct Richard with the blueberry. So is he closer or farther? Farther, okay. Like that? A bit more? Got to vote for more? Anyone else say more? Okay, I'm seeing a lot of more. Okay, a little bit more. Is that perfect?
Yeah.
Okay, that's perfect. Okay, so put the blueberry here. Put the blueberry right here. Okay. Good, perfect. Blueberries can see it. Okay, so what's next? Earth. Did they get grape? Interesting. Okay, almost the size of Venus. So on one hand, who thinks it should be a grape? Okay, and then other hand, who thinks it should be a blueberry? Okay, a lot of blueberries. So let's grab another blueberry. Okay, where does the blueberry go? Which side? That way or that way? That way. Okay, let's keep going this way. Is that far enough? Okay, a little bit farther, maybe? Is that far enough? Yes? Okay. Let me put this right here. Okay.
Yeah.
No one's allergic to blueberries, right? I should have asked that. Sorry, my bad. Okay. Okay, so Mars. Which of these objects? Mars bigger or smaller than the Earth? Smaller. It's smaller than the Earth. So now we're going to go to. Was that breath mint again?
Yeah.
Everyone vote for breath mint or no? Okay, all right. Grab a breath mint here. We need a second breath mint because that's where Venus was. Or sorry, that's where Mercury was. Okay, so where are we putting that? Okay, so that's where we think the Earth is that correct? Okay, let's keep going. Is that good? A little bit more. A little bit more. Okay, let's put it right there at the end of the table. Is everyone like that? Okay, all right, we're getting there, we're getting there. All right, Jupiter,
Oh, very good.
cantaloupe? People want this to be cantaloupe? This is Jupiter? No, why not?
Oh.
What's that? Hold on, what's that? It's bigger than the sun, so it's not bigger than the sun. Okay, so which of these would be Jupiter?
Or the one. One.
Yes. Orange. Okay, so I hear orange. Anyone like orange? You like orange. Okay. All right. Where are we putting Jupiter? Okay, so now we can't go in a straight line because unfortunately it didn't give me an infinitely sized classroom. There's a budget for that. So go ahead and walk in this way. You'll notice that this is actually still a longer distance because of Pythagoras theorem. You know that walking this way is longer than walking this way. Okay, keep going. Is that good?
Yeah.
Okay. If we put that right there on the edge, put that far enough? Everyone's happy with this.
Yeah.
Okay. And what about Pluto? Yes. Oh, interesting. What's this? Little rocks. You want this to be Pluto? Is that correct? Is that what you'd like? Okay. How about this? Is this rock the right size? Go bigger. Bigger or smaller? Smaller than this rock? This one right here? Yeah, you like that? Okay, where are we putting Pluto? I just barely even got it in his hand. Is it farther than Jupiter? Okay, so you have to go a couple stairs up, maybe? That far enough? further. Is he in the room if he's holding Pluto? No, he's not in the room if he's holding Pluto. Okay, so how many of you do you think you got right? If sun's the size of the grapefruit? Let's put money on the table, right? Everyone puts $10 down. Okay, and if I'm right, I get all the money. Does that seem right? Okay. What if I told you that you didn't get any of the sizes or the distance? Would you be pissed? Yeah, what was the point? Okay, so let's do it properly. It turns out that Mercury is the size of a piece of salt. So where we use this, that's incorrect. And in fact, you have to grab one of these guys. Can you see that? Okay. Okay, and then you need to walk 19 feet away. About there. Okay. And Venus was a ballpoint pen tip. And that's about, oh shit. Sorry, I lost it. Okay. So it's about that one there. And it's about 36 feet away. Okay. About there. And the Earth was about the same size. Okay. And that's about 50 feet away. That's about 50 feet, right? Okay, so Mars doesn't even fit. Mars is 75 feet away on the scale. Jupiter is 250 feet away. Can we think about the scales here for a second? That's a lot of empty space. When we see in Star Wars and it takes 5 minutes and you go from one place to the other, you go through the asteroid belt and there's all these rocks. No, there is nothing on there. You go into space, it is empty. Nothing. Okay, so you go from there. Which one was Earth? Which was up there, I think. All of that distance. Nothing. Okay. Where's Pluto on this? Well, it's really, really small. And in fact, at Pluto's distance, the sun doesn't even look that interesting. It's so far away that it mostly just looks like every other star in the sky. It's a little bit warmer. Size is quite small. About a third of a mile away. So I wasn't going to send him a third of a mile away. Okay. Fun demonstration? Okay. Well, why did I bring all this extra fruit? Okay. The nearest stars form a system. Yeah, you can sit down. Oh, thank you. Yeah, I'll need that for this system. Okay, so this is our sun. About this big. Okay, as we did before. The nearest set of stars that we could travel to is the Alpha Centauri system, and it consists of 3 stars, one of which is about the size of a cantaloupe, one of which is the size of an apple, and the other is the size of an orange. And they would be located in New York City. That's a long way to go to see if there's anyone else in the universe. That would be our nearest neighbor on this scale, right? Is like that was the Earth. This was the sun. This was the Earth. And then our neighbors are New York City. Okay. Does that give you a perspective for the types of distances we're going to be talking about here? Okay. Okay. So that's the first part of this. You have 9 minutes. You have questions about this before we move on to the next section? Okay. 2 demonstrations in one. Okay. I'm gonna put up these here, and Does everyone know their astrological signs? Okay. Not gonna necessarily ask you for them, but I am going to have you come up and grab whichever one corresponds to you, once I put them all out. You're gonna hold on to them for a few minutes while we talk about the beginning of this content. Oops. And then. Oh my gosh, there's no space. All right. So come and grab your month. Just hold on to it right now. You don't need to get into it. Oh, no, not that one. Just the white one. You can keep that too, I guess, later, but. Okay, so before you really dig into these, oh shit, I ran out.
Yeah, well, yeah, I was about to say.
There's a lot of Libras. Okay, well, sorry if you're Libra, you have to sit down with that. Wait, don't compare them, don't read them. My goodness. Some of you. All right, so we're gonna talk about the nature of science. We're gonna do this with a fun little comic. If you've ever read XKCD, this is like a nerds comics. So here you have a human being, they pull a little lever, they get zapped. Normal person goes, guess I shouldn't do that. Scientist says, I wonder if that happens every time. So this is an important aspect that we're going to discuss. It's called reproducibility. And this basically means if I do the same thing, will the same thing happen twice? Okay. Scientific theories, when we discuss them, people say, oh, well, that's just a theory. What does theory mean? We're going to have a discussion about what does it mean to have scientific knowledge. When you hear someone say, well, I did market research. Okay, well, is market research science? It's not. So we'll discuss all of these different parts. Okay, so we're going to discuss how we address the nature of science and the science of nature. They're both one and the same because it turns out that we're human beings, and human beings are not infallible. Did anyone know that? They have flaws. They make mistakes. They're biased. Shocking. Okay, so we're going to identify what are scientific and non-scientific questions because we can't answer everything. We have to know how to tell the difference. Okay. We're also going to talk about the scientific method, although not today. We're going to talk about Fermi problems, the application of a critical mind, and this will set us up for how we're going to start talking about people just standing outside for thousands of years, looking at the sky and learning. Okay? Couldn't do it for 5 minutes anymore, right? Okay, so we picked up the horoscope. So now we read them. You don't share them. Okay, so instead of having clickers, I don't necessarily like that technology. We're gonna do like clicker questions, but it's easy to do because we have access to multiple digits. If you don't have access to multiple digits, let me know right now. We can find another way of doing this. So I'm gonna ask a question. I'm gonna say, how well does today's horoscope describe you? And you're just gonna show me A, B, C, D with this four-fingered A. I guess I should have put 1, 2, 3, 4. I'll learn that next time. Okay. So what we're gonna do is we're gonna say, you're just gonna put your hand up just in front of your body, so that I can kind of look around, see what your response is. How well does it describe you? Very well. They identified everything correctly. Too well. They identified most of what I'm feeling. C, acceptable. They identified some things that I'm feeling. D, poor. They identified things I'm not feeling. Let's see. 1, 2, 3. That's a hand up, or is that
1 for A.
so like this?
Oh, sorry.
Yeah, no worries. That way I can just see at the same time. Okay. All right, a lot of 2s, 1s, some 3s, a 4. Okay. And of course, the major reveal is they're all the same. Why would I do a trick like this? Why? What am I doing? So what about the horoscope made it seem accurate? Yeah.
I felt like it was not super descriptive, like it was vague enough for us to like match certain people, but it was like it left out enough detail.
Our brains are really good at like filling in information, especially when it's like, oh yeah, that is really about me. And that like sticks to you. And then the part that it's like you're a coward, you're like, how can I read that part? Right? Are there any parts that seem too coincidental to be true? Or too true to be a coincidence? Right? Yeah. Yeah, right? And those stick out to your brain. Like, what? That is me. I am like that. Right? Okay. Was it obvious you had the same one? I know you do. Okay. Did you know that that was the goal at the beginning? Okay. So one of my favorite demonstrations, because what it does is it really points to what are we trying to say with science. Okay. We talked about reproducibility as being a part of the scientific process. But we also have to understand something like predictive power. How well can we predict the future? We'll talk about that in a few seconds. So we have some driving questions. How do we distinguish science from non-science? Right? What is it meant by scientific theory? And how does astrology with the G differ from astronomy with the NEM? So if you're here for astrology 1010 or 1000, I have very, very bad news. In fact, will not be learning any of the horoscope prediction business. Okay. And what's the scientific validity of astrology? 0. Now, does that mean that it has no value, or is it the scientific value? Okay. All right. Let's be careful to keep these things in mind, because different people have different values that they place in all different ways that we describe our life. So we're not going to stand on a pedestal and say, I can't believe that you believe in astrology, but it's not astronomy. Okay, so we have to distinguish these two if we're going to have an astronomy class. Does that make sense? Especially if we're going to talk about planets. Okay. So is luck real? Raise your hand if you think luck is real. 1, 2, 3. What if you're like wishy-washy and you don't want to be tricked by anyone, right? Tricked twice, you made us stand in the wrong place. We all have the same horoscope. This isn't fun. Okay. Is luck real? Well, let's think about how we could possibly test this. So I always say, like, oh yeah, well, if I was going to be really lucky, like the person was really lucky, a lot of good things would happen to them, but maybe they just like are rich, and so good stuff happens to rich people. Like they get free stuff all the time. So maybe that's not a good idea. What if I were to test, like, does everyone have a favorite number? Yeah, people have some favorite numbers. You have a lucky number? No one has a lucky number in both. Wow, yeah, you have one? What's your lucky number? 7? Okay, so we have these concepts and we say to ourselves, how would I test if my lucky number? Now, of course, it's a feeling, right? So I'm not gonna say that your lucky number is not a real number. But my idea is like, if I were to create a scientific test, what would I do? How could I possibly tell? Is it possible to tell? The nature of science is determining what questions we can and cannot ask. Okay? So you could be like, well, it was a lucky goal, right? That would have never gone in. But then you watch them in practice, 9 times out of 10, it goes in. Like, was that luck or is that skill? Right? So you say maybe lucky numbers should win the lottery more. Let's look at the data. Right? Those are numbers, those are results. And it turns out that if you look at the Mega Millions white ball frequency distribution since June 2005, is there a clear winner? 48. Everyone's saying, oh, 48 is the only one, right? They're kind of all about the same, right? Like it doesn't, like, okay, here's 1. Okay, and on this distribution, yes, this is a little bit higher, but not by a lot. Does that make sense? Right? So like, if my favorite number, right, 9 was the luckiest, I would want to spike right there. I just always play 9. But in fact, I played and I didn't win $2 billion. Right? Okay. So we can talk about the distribution of lucky numbers, whether or not we can tell that luck is real or not. Another way to think about this is, right, the difference between astronomy and astrology. Okay, they both have roots in the motions of the skies. So you'll hear someone like, the moon is in Sagittarius, and that's why I'm really rude to you today. So some people would say very scientific for astrology. Most people say not very scientific for horoscopes. They're the same. Okay. That's fine. Astrology attempts to use the position of the planets, sun, and moon to explain occurrences in our daily life. Okay, that's a postulated belief of astrology. It can also be used to start a dialogue, right? So if you want to have a dialogue about your day and maybe to put yourself on the right foot, great, let's use it for that. But there are people who will make you pay for your horoscope. Anytime that anyone is having, I have secret knowledge and you're going to pay me for it, that's not science. Okay, you can find everything that's scientific for free. Okay. So astrology is the study of, Okay, astronomy is the study of objects outside of our planet in an effort to understand them. This should have been on top. That's a telescope. And we're going to talk about what are the specific ways in which they interact. So how do planets interact with one another and by what mechanism? Okay. That's the limit of their similarity. They both talk about motions of objects in the night sky. Astrology lacks consistency. And I'll show you that in 2 seconds. It lacks predictive power. That is, it doesn't tell me how my day is going to go. And it lacks a physical mechanism. You need all of these for a scientific theory. So when I say it lacks consistency, what do I mean by that? So today I looked at my horoscope and it said, things could be rather hectic at work. I was like, yeah, it's fucking crazy. Okay, so you'll probably be very busy and happy with whatever results you produce. Great, I'll just do whatever I want, but I could tire myself out, right? So I should go out for dinner and unwind. I deserve it. And then the second one was, should you get involved? This was from Al, reputable source of astrology. And it said, jump into the fray. Well, so do I want to get dinner and unwind, or do I want to jump into the fray? Extend the olive branch and persuade both parties to take hold. And I was actually pretty impressed because the next one that I found actually did have a little bit of like holding tense negotiations and equilibrium. But then I wondered, maybe it's my brain just picking out the pieces that I think apply to me, right? So there's no consistency in the prediction. So if I told you that when I throw a ball, sometimes it would land here, and sometimes it would land here, and sometimes it would land here. If I threw it in exactly the same way, you'd be like, what? No, that's not correct. So if I throw a ball at the right speed, the right velocity, it always lands in exactly the same spot. Right? Right or wrong? Yeah, okay, good. It lacks predictive power to be considered scientific. It should be making testable predictions. You already said it doesn't. Claims to use the sun, moon, and the 8 planets to make predictions. And we didn't always know about the 8 planets. Pluto was only found out about less than 100 years ago. Or a little bit more than 100 years ago. We didn't know about Uranus. We didn't know about Neptune. You needed telescopes. Okay, but those have been in astrology for a really long time. So how could you make predictions about that? I don't know. So why weren't they all wrong? And more importantly, does the removal of Pluto to a smaller body, does that affect its power? Because of course Ceres is closer. It's in the asteroid belt. It's not quite as big, but it's a large object. So should that be included? No one likes to have a conversation with me about that. And finally, and most importantly, is the physical mechanism. Okay, there is no physical mechanism that connects these objects to our daily lives. Okay, what do I mean by that? Okay, gravity, electromagnetism, these are fancy words. Someone may try to lull you to sleep by throwing fancy words at you and saying, I can predict your future for only a small sum of $69 per month. You will feel better because I know the impact these things have on your life. And I'll share the secret knowledge with you. If you want it, take it for free, but don't pay for it. Because there's no predictive power and there's no physical mechanism. When we talk about electromagnetism, okay, we talk about, say, the gravity of this cantaloupe. Okay, it's not attracting me. I'm not getting pulled to the cantaloupe. In fact, I'm holding on to it. Okay, that's an electromagnetic force that does not allow it to go through my hand. If you're a biology student, chemistry student, you know that it's the bonds within atoms and within molecules that allow things to be held onto, right? That's an electrostatic force, not a gravitational force. And in fact, when you say, well, you know, what if the electromagnetic force of Jupiter is really affecting my life? Jupiter's magnetic field has the same strength as your toaster. So if you have to account for your toaster in your daily life, I mean, I do, because I like bagels in the morning. But if you do, this is something you should consider. Okay. Okay, so we are actually going to talk about what is testable and what is not testable. And to do this, we're going to talk about which of these can be tested by scientific means. Okay, so have a few seconds to read this. I'm going to read it out loud, and then we're going to do the same thing we did before. I'm going to ask you to just put up your hands. 1, 2, 3, 4. I really should change these from A, B, C, D to 1, 2, 3, 4. And we're going to find out what we think. So it says, which of the following claims can be tested by scientific means? Methods, yeah, means. Is A, blue the best color for walls? B, people born when the sun is in the constellation of Leo are more financially stable? C, God exists? Or D, the final thoughts of Abraham Lincoln were about the fate of his country? And if you're ready, you can just put a fist up, so I can tell you already. Okay, ready on 3, 2, 1. Now you show me how many fingers corresponding. So I see a 4. I see some 2s. I see a 1. A couple of 3s. Okay. Does anyone want to defend their decision? Yeah, that's right. You can get my attention if your hand is up.
I chose A
Mhm.
because, like humans have like different reactions to color.
Mhm.
So depending on like what reaction you have to do, it might be different.
Yeah, so this is actually a pretty good one. Blue is the best color for walls. The only problem is that it didn't state it very well. So it's not quite scientific because it's not for something. Best needs to be with respect to something else, right? So if I said blue is the best walls for calming babies between the ages of 2 and 4 in the US, that could be tested. If I said it's the best color for all wolves,
Yeah.
it's a little hard to test, right? Okay, so that one was a trick, sorry. What about this one? The final thoughts of Abraham Lincoln. Do we think that's testable? No.
No.
Do we think God existing is testable? No. Do we think people born in the sun when the constellation of Leo are more financially stable is testable? No. So no or yes? How would we test that?
Checking your dates and their financial status.
There you go. So let's take a sample of the population, grab, say, 100 people, ask them for their birthday, and then rank them by their net worth, their correlation. The answer is no. Okay. So some things are testable, some things are not testable, and some things have to be amended. There's some questions that exist, you're like, that's kind of scientific, but you need to rephrase the question. So some people will say, well, what happened before the Big Bang? Is that scientifically testable? No. Because we don't have access to what happened before the Big Bang. Because there's no light. And that's what we use to communicate. We use light. I can see things. There's no light, I can't see them. Right? Okay. So that's where we'll stop for today. I'll see you on Tuesday. You don't have a lab. If you have any questions or anything else, go ahead and hang out here and I'll answer them. Okay. No, you can keep it. Yeah. Oh, sorry, go ahead. You first. Thursday. What about you like? Yeah, no worries.
So before the Big Bang was there's no time. Right?
Yeah, well, that's when we start counting.
So the answering homework,
Uh-huh.
it's set up, it's something about exposure to gain access to it.